Hi everyone. Today I would like to give the presentation on MISRA C 2012 standard. Okay, what is MISRA C 2012 standard? MISRA stands for Motor Industries Software Reliability Association. It is an association developed for automotive industry, especially for automotive industries, to identify the software bugs in the code. I will repeat once again. MISRA stands for Motor Industries Software Reliability Association. It is developed for automotive industries, especially for automotive industries. It produces safe and robust C. Here in MISRA C, it has 127 rules. Okay, 34 are advisories. In 127 rules, 34 are advisories. What is this MISRA C 2012 standards? The advantage of this MISRA C 2012 standard is it will minimize the software bugs, or it will remove the software bugs. It will increase the code. It will decrease the. It will perform the code optimization. Okay, it will decrease the code size, portable code. It will decrease the code size, and also it will make program as predictable manner. It's nothing but, okay, already you know that is ABS, anti-lock brake system. In that software, the code should execute within a particular period of time. The deadline is very important in ABS systems. So how to check that code is working properly or not? Using this MISRA C 2012 standard. MISRA C 2012 standard is to check the code whether it is working properly or not, efficiently or not. Okay. How it will perform testing? See here LDRA. What is this LDRA? This LDRA peoples are developing MISRA C 2012 standards. Using this LDRA software, I can easily identify the bugs in the softwares. Here, first is testing. What is testing? Here in the testing, I can perform requirement based testing. Based on the requirement, we are performing the testing. This will achieve 100% code coverage. And also one more is there, functional testing. What is functional testing? Which is input, which is output. What is the function? Logical operation. That's functional level testing. The first one is the requirement testing. In requirement testing, how to perform requirement testing? First we define a requirement. For example, you are doing a half order program. What's half order? You are performing a sum and a carry. What is sum? Is nothing but a plus b is the sum. You first define the requirement. First you define the requirement and then you develop a code and write a test cases. What is A, what is B, what is C? Write a test cases here and then verify the requirement whether you meet the requirement or not. That is requirement based testing. Okay, that's an example. Then functionality testing. What is functionality testing? In functionality testing, we check the correctness whether it is working properly or not. Robustness, error guessing, fault injection, analysis of a boundary value. Here in functional testing, we identify the correctness, robustness and error guessing and a fault injection test. That is called functional testing. Two tests, one is requirement testing and second is functional testing. In requirement testing, based on the requirement, we develop a test cases. In functional testing, we analyze the correctness, robustness and error guessing of the given product. In functional testing, one is low level testing. What is low level testing? Testing on actual hardware, testing of the actual hardware, either a white box or a black box. What is white box testing? In white box, the tester know the logical relationship between input and output. He must know the logical relationship between input and output. What is black box? The tester doesn't know what is there inside the box. Just he will apply the input, see the output. That's called black box, like a blind method. In white box, he will know the each relationship between input and output. That's white box, and second is black box. Two testers are available in the market. That is black box tester. The first one is white box tester. That's one more important point. Okay, here in MISRA C, okay, you can expect a question like this: write a stepper motor program and check the bugs in the stepper motor program. At the time, you should check the functionality. You will perform functionality testing as well as requirement testing, and also you should only give the test cases. The second is optimization. What is optimization? Optimization means while writing a program, we simply add some variables, dead codes, etc. How does that dead code, that's that dead code variables increase the size of the code memory? How to decrease the code memory size? Using a optimization. Decrease the code. Here we can see some levels are there here. The levels are compile level. During the compile level, we can perform the optimization. Assembly level. In the assembly level also we can perform optimization level. Runtime level. Okay. While running the program, we can perform the optimization. Okay. We will discuss one by one. First we have to know types of code optimization. An example: dead code optimization, loop optimization, and common sub expression removal. What is common sub expression removal? See the program here. This one program: A is equal to B into C plus G, D is equal to B into C into D. Here in the common sub expression elimination optimization, that instead of identical expression, okay, they all evaluate the same value, we can replace that with a single variable holding computed value. For example, here, see here, I can replace this program with this. Instead of using B into C plus G, I can use temp is equal to B into C. Later I can add with G, and then later I will take the value into A, and then I am taking temp into D here. Okay, instead of writing this, I can use this one, common sub expression. Okay. And also, what is the problem here? Here there is a problem in the C or a B or a G variable. It will affect entire A value. So here I am replacing this with this one. Second is dead code optimization. What is dead code optimization? Dead code elimination is a compiler optimization that removes code that does not affect a program. Dead codes, that codes the program doesn't require that code. That code can be eliminated. Okay, simply, for example, NOP, no operation. I can simply remove that no operation because that no operation requires some machine cycles. Okay, removal of such benefits, shrinking program size. What is the benefit of dead code elimination? It will decrease the program size. That's a very important in the dead code optimization. Okay, we will discuss in the kill optimization tool one by one. Second is loop optimization. Loop optimization plays an important role in improving the performance of a source code by reducing the overrides with executing loop. Instead of using some unwanted loops, I can simply remove it. Loops of invariant, induction variable, etc. Okay, I will give a simple example. See here, this loop invariant is an example. Here I is equal to 1, S is equal to 0, do is equal to S is equal to S plus 1, A is equal to 5, and I is equal to I plus 1. Instead of using this program, I can replace this program with this guy. Bringing A is equal to 5 outside the do while loop is called code motion. Here I can simply replace this program with this. I can take A outside the do loop and write it like this also. Okay, that's called loop invariant here. That is called loop invariant. The thing is, see here the A is a constant. I am assigning A is equal to 5. I can assign this in before the do loop while also. You can ask a question, so what is the use of this one? See here, if I repeat the loop 10 times or 15 times, it will allocate A is equal to 10 times or 15 times. Simply it will wasting of the machine cycle. Simply it will waste the clock cycle time here. So instead of taking A is equal to 5, I can come out, I can take A is equal to outside the loop, that is A is equal to 5, and then I will perform the looping operation. Correct? No? Here in this program it required one more cycle for A. It will repeat 10 times, means 10 times the A is assigned by 5. In this case, initially it will assign by 5, later it will perform the operations. Correct? No? That is called loop invariant. Like this we will optimize the code. We will discuss one by one using kill optimization tool. Here, see the kill optimization tool, it is also available in the kill software. See here, some program is there. One program is there, stepper motor program. Already you saw in the 8051 microcontroller lab. This one code is there. Okay, here in this code, okay, simple program is there. That is ADC. Okay, ADC, analog to digital converter program it is. Here, see here. Before I start, first you build the code. See here, what is the program size? The code size is 486. See here, the code size is 486. How to optimize this code? Here, go to C51 library and select level Okay, here you select a data overlap. See here, dead code elimination. What I had explained, dead code elimination, removing of dead codes, removing of dead codes. It is dead code elimination, data overlay, register variable, common expression elimination, common expression. What I already explained. Okay, that's what we see here. Just to select any one of the level and click OK, and then select and then build the program. See here, now the code size is 479. Okay, each level will try to decrease the size of the code here. Try to decrease the size of the code here. You can take any code optimization techniques here and then you build it. Okay, now see here. Take an example. Now the code size is 551. You can take C51 and take any levels. Some 9 levels are there here. Okay, 9 levels are there here. You can take any levels. Constant folding or data elimination, etc. Click OK and then build it. Okay, now we are in a code elimination only. Okay, take one more. That is register variable, common expression you take, select. See here, initially it is 551, now it is 479. The code size was decreased. Okay, using this keys C51 optimization, we can decrease the code size. Okay, thank you.